Hello. Today I am going to talk about powering SP networks for AI with Cisco Silicon One. AI is no longer confined to data centers. The subscribers, home users, and enterprises are exponentially adopting AI applications. No two prompts in AI have the same context, history, and word structure, making every prompt unique, which makes caching highly impossible. Today, inferencing, AI powered applications, and model training are getting distributed across metro regions, metro edge, and centralized GPU clusters. In addition, autonomous AI agents are increasingly collaborating with each other in any to any communication mode, driving high volume, low latency agent to agent communication between geographically dispersed AI clusters. Every AI request produces a large number of tokens, resulting in traffic patterns that service provider networks were not originally designed to handle. There are massive inter-DC traffic flows, long-lived fat flows, disproportional increase in upstream traffic, bursty demand, and to top it all, a strict sensitivity to latency. The result is simple. AI is breaking the assumptions behind traditional IP network designs built with fragmented ASIC families. For service providers, this shift is creating real architectural stress. The access ring must upgrade from 25 to 104 gig. The edge needs to be distributed for your network to be agile, and power efficiency per bit is now a hard design constraint. The transport network must scale from 100 gig to 400 gig to 800 gig and beyond. The protocol stack in the network needs to be simplified and programmable with support for protocols like SR, SRv6. The end to end network visibility is important for creating network slices based on AI workload demands, where latency or higher bandwidth can no longer be best effort. Telemetry must move from coarse visibility to real time insights into the network and device health. AI training and inference workloads are distributed between data centers. So the interconnect between the DCs and stitching of two different VPN services becomes very important. You would need short and ultra long haul optics to optimize your fiber cost. Many networks today are built on fragmented silicon strategies and legacy architecture. That fragmentation increases operational risk just as AI demands more predictability. So the challenge is not just speed, it is architectural consistency at scale. In the AI era, along with support for features like multi-homed EVPN, SR, SRv6, routing silicon becomes the foundation of network behavior. The ASIC first approach from Cisco leads to a single unified architecture across access, aggregation, edge, core, and data center. Cisco Silicon One was built with this reality in mind. Q200, a 12.8 terabit second generation ASIC from Silicon One family, is specialized for core or transport network use cases. Cisco's continuous investment in ASIC enabled the third generation of Silicon One to cater to three different segments. P100, a 19.2 terabit ASIC for core and peering use cases that requires a good scale of counters, NetFlow, ACLs, and BGP flow spec rules for better accounting and DDoS protection. K100, a 6.4T ASIC built for aggregation and edge roles that can meet the feature requirements for building an agile and distributed network. It has decent scale of L2 VPN, L3 VPN services, pseudo wires, ACLs, QoS policies, and counters, and a specialized A100 ASIC to cater to low speed and access specific features and scale. Both K100 and A100 has built-in crypto engine to build a secure network with the help of protocols like MACsec and IPsec. Silicon One has one common SDK across the portfolio, which means same forwarding behavior, telemetry model, and operational characteristics everywhere in the network. The power footprint of these ASICs is approximately zero point zero 0.05 watts per gig, and latency in non-conjunction scenario is approximately 5 microseconds. Cisco has continued to build the momentum with the fourth generation of Silicon One ASIC, which is P200, a 51.2 terabit ASIC in 3nm design with 112 gig service lanes to enable native 800 gigabit Ethernet speeds. And this also has built-in crypto engine to enable functionalities like MACsec and IPsec. This chip will be delivering 51.2 terabit capacity in a 3RU form factor. Silicon One is built for massive bandwidth, scalability, and deterministic network performance with best in the breed power efficiency per terabit. The consistency removes architectural seams and allows networks to scale without introducing any complexity. The Cisco 8000 series router family brings Silicon One into the real world service provider networks along with feature rich and industry hardened ISXR. With complex feature support such as interworking of SR-V6 and MPLS or SR-MPLS islands, stitching of eVPN MPLS to MPLS based VPN services, the list of features supported in XR are endless. So let's bring our focus back to the products. Cisco 8000 series routers are designed around the Silicon One network processing unit in a fixed, centralized, and distributed form factor, enabling speeds from 1 gig all the way up to 800 gig with wide range of optics including ZR, ZR+, long haul, and ultra long haul optics. The second generation Q200 powers the core and peering use cases with systems delivering a throughput capacity of 5.6 terabit to 12.8 terabit in fixed form factor. The centralized system with modular port adapters can deliver 12.8 terabit with redundancy at multiple levels. The line cards seen on top are for 8800 distributed systems that provides full redundancy at control and data plane. The third generation of NPU, P100, powers aggregation and edge use cases along with core and peering. The fixed system can deliver 19.2 terabit capacity, and the line cards can deliver 28.8 terabit per slot with 36 port of 800 gig ports. That's the maximum capacity. The same NPU can deliver 12.8 terabit in aggregation, peering, and core use case in fixed form factor and 3.70 and 12 terabit with modular 8800 family. The third generation NPU also brings in specialized edge silicon, primarily built for distributed edge networks. It has systems starting from 5.60 and 6.40 in fixed form factor. It delivers highly redundant 4.8 terabit 8404 system. This platform provides redundancy at every level, including control and data plane. The two line cards on top of the column delivers 4.8 terabit and 9.6 terabit throughput for 8800 family. The A100 family powers the Access portfolio with systems starting from 240 gig all the way up to 1.6 terabit. When the same silicon architecture and the same operating system spans the portfolio, service provider gains consistent behavior from access to edge to core, simplified validation and upgrade cycles, faster deployment for AI driven services, enabling new monetization opportunities. The result is a network that scales with AI operationally and economically. AI growth is not linear, and networks must scale faster than compute. The service providers who succeed will be those who build AI ready networks that are architecturally consistent and have power and performance optimized one silicon story, flexible service delivery with high performance and reliability, and a simplified core network, and DC interconnect with ultra long haul optics, operational simplicity with end to end automation and assurance. AI may run on GPUs, but it depends on the network. With Cisco Silicon One powering the Cisco 8000 series routers, service providers can build networks ready for the AI era today and into the future, bringing in unparalleled customer experience and new monetization opportunities. Please visit cisco.com case studies to understand how our customers have optimized their OPEX and CAPEX using Cisco Silicon One based 8000 router family. AI is forcing service providers to reinvent their network, and Silicon One powered Cisco 8000 is built for that future. Thank you.